is Dmitri, and I'm leading a team that develops speech technologies in a company called Active Business Consult. So we are a subsidiary company of Sberbank of Russia, and we were created to work with debt collection, and a major part of our work is operating a high-tech call center that we own ourselves, and we also invest heavily in technologies and automation. So, and we like machine learning, we like AI, so we use it extensively. And today I want to talk to you about our flagship product in automation. So it's a system that can replace human agents in a call center and perform many of the routine tasks that they were performing. So agents in a call center, they make hundreds of calls per day, and these calls, they are nearly all the same. So this is made worse by the strict regulations that we have that impose things that we must say during conversation with the debtor. So this is a really routine work. And also our agents, they face many negative emotions from our debtors because they are not happy to hear us. Sometimes they get angry. And so all of this leads to the agents burnout. And so when they burn out, their performance decline, and we get a high staff turnover, so all of this adds up to our cost of operation. So if we want to automate this process, what we need to do? So first of all, we want a system to sound like a human, so we need a good speech synthesis system. We want to understand what our debtors are telling us, so we need an accurate speech recognition system. We also want to be able to switch to a human agent if anything goes wrong and our robot cannot solve their problem, so that hopefully the human can solve it. We want to work with scenarios of varying difficulty. We want integration with the company's CRM so we can load data and use it during the call. And we also would like to know the age, gender, and ideally emotions of the other side. So, for example, when we call and we say like, "May I hear Baliev Dmitri?" and then we hear a response with a female voice saying yes. We don't want to ask, "Is it you?" So that would be awkward. So what are the advantages that such a system would give us? We would get high efficiency, and we would get a high scalability. We also would reduce costs, and we will reduce legal risks, and it will be simpler to adhere to guidelines, just because we cannot diverge from the script. And also we will be freeing people from this routine work, so it's always good. What are the fields of use for this technology? Well, it's everything where the scenarios are not overly complex. So for example, we use it in debt collection, we use it in telemarketing, informational services, etc. So we're actually using this technology extensively nowadays in our own call center. We do more than 200,000 calls per day and more than 5 million calls per month. And we're also facing some challenges when offering this technology to other businesses. So the main challenges are the low awareness of the capabilities of such systems and underestimation of this technology, which leads to people not using this technology in fields where it's effective and trying to use this in fields where it's not effective yet. So now I want to briefly talk about the key technologies that allow us to create this robotic system. So the key technologies here are the speech recognition system, the speech synthesis system, and the scripting system. So let's start with the speech recognition system. So here is the outline of our pipeline for the recognition. So we start by trying to denoise the audio that we get and to find where the speech actually is. Then we use a combination of a phonetic model and a language model to actually form the hypothesis of what was said. And then we try to score this hypothesis based on how likely this combination of words is actually to happen in the language. To train this model, we use a data set of more than 2,000 hours of speech that was collected in our data center. And we have regional accents from all over Russia. And this is very important for us because this allows the system to work well in all the regions. And with the system, we achieve a word error rate from 7 to 19%, which is pretty good for telephony, but it's Still, it gives us some errors. So just for comparison, the believed word error rate for humans is around 5%. So it is a little bit worse than that. So what can we do to deal with these errors? Let's see an example. So we got 3 hypotheses from our recognition system. The first one is that our client said March the 1st of 2050, and it is the highest ranked hypothesis from the recognition. And then we have another hypothesis. So he said March the 1st of 2019. That makes no sense. And we have a third hypothesis that he said March the 1st of 2015. And we can have some other information sources. For example, we have data on a CRM that the correct answer for this question may be March the 1st of 2015. So in this situation, we can pick the certain hypothesis and we avoid asking this question again. So this leads to a better dialogue flow. Another system that we use is age and gender recognition. So we looked at a bunch of recordings from a call center, and there is a high correlation between the pitch of the voice and the gender. So male voices tend to be of lower pitch, and female voices tend to be of higher pitch, as shown in the spectrograms here on the slide. So that led us to the idea that we can use actually a pretty simple neural network architecture. It's comprised of several convolutional layers, and we just feed the spectrogram into it, like just a 2D image. And we actually achieve a pretty good score. So we achieve 97% accuracy for gender recognition, and we achieve ±6 years accuracy for age recognition. So that's pretty good. Next, let's discuss the speech synthesis system. And here we actually use a combination of pre-recordings and neural speech synthesis. So we can broadly classify the text that we want to say into 2 categories. First is the fixed texts that never change. And we can pre-record them and forget about them. And we also have some variation parts when a part of the phrase or the phrase itself may change from call to call. And so, on a small scale, we can also use pre-recordings. But if we want to scale up, we need another solution. So we use an architecture that is based on Takatron 2. It's a neural architecture that was proposed by Google in their paper. So to train this model, we use more than 30 hours of high-quality studio recordings that we annotate. And one of the big problems with the Russian language is its reflective language, so it is a little bit more complicated to annotate it than English. And we actually have to put stresses in all the words, we have to perform unification, and we also have to perform phonetic spelling for some things. For example, you say ABC, you don't say EPS, so we also need to annotate this, so our system works well in this case. So it is a little bit hard to score a speech synthesis system because there are no objective metrics for it. So I want just to give you a quick demo. So these are the audio samples that were with the original Google paper about speech synthesis. So this is what you can expect from a good speech synthesis system nowadays.
Basilar membrane and otolaryngology are not autocorrelations.
And also, speech synthesis systems are actually very good at tongue twisters, so...
Peter Piper picked a peck of pickled peppers. How many pickled peppers did Peter Piper pick?
Okay, so we have our recognition and our speech synthesis, and now we have to do something with it. So for that, we need a flexible scripting system. So when we talk about a scripting system, generally people imagine something like this. So we may ask a question, get an answer, classify it, and maybe make a decision there. But the reality is actually more complicated. So this is actually one of our simpler scripts in our system. It looks like this. And we need to deal with many things on the level of the script engine. So we need to deal with the local context of the question we are asking now. We have to deal with the global context of the conversation as a whole. We need to deal with loops in conversations. We need to deal with interruptions from the client, so he can say, like, for example, "Oh, sorry, my pizza has arrived." And we also want to incorporate complex logic. So, for example, we can ask for things like, when can you make us the payment, or like how much money do you have right now, so how much can you pay us, so like maybe you can pay a fraction. So, and we need to perform the calculations on the fly to decide where to go next in the script. We also have to deal with broken dialog flow. So when, for example, we had a team in the conversation, then we diverge from it, and we return, and we need to bring back the context that was there. So for this, we actually developed some instruments. So we have a custom system that's based on a JSON language. We use word-level regular expressions to pattern match the replies from the users. And this has proven to be a pretty robust system, but it's actually pretty hard to write, so we spend much time writing these expressions, but they work really well. We integrate complex logic, so actually we can do anything that is possible in a programming language, because we actually inserted a scripting C# language into this scripting engine compiler. We also make automated tests for the system, and one of the better sources for these tests are actually the calls themselves. So we can have a pilot project when we use our human agents to perform calls. We record them, and then we annotate how we should behave during this call, and we can create tests based on this annotation. And we also make the system for monitoring. So we want to be able to look at any call that was made by our system. We want to look how the decisions were made and why, so we can insert corrections if anything goes wrong in the production. So we have systems for this. So here are some screenshots of different parts of our software that allows us to write the scripts. And one important point I want to make is that this all seems really complicated, but we actually found out that we can educate people with no software development background to write the scripts. It takes about 3 months for somebody to learn all of these instruments and start writing scripts that can go into production. And so this is an efficient system, and we can actually find people, educate them to work with the system. So I give you an overview of the technologies that are underlying our system. So what are the performance of the system? So when we introduced it in the production scale, we actually measured some metrics, and measured how many erroneous and how many correct results we get. We measured how many times we misunderstood the client and went the wrong way. We also measured the performance relative to other agents that we have in our call center. So we achieved 97% of correct results, and we surpassed 77% of human agents in our call center. So where do we go from here? Well, we want to go in several areas. First of all, it's improving the decision making for our system. So we want to incorporate what is called emotional intelligence. So we want to understand the emotions that the user is saying to us. We want to understand the confidence that he's saying, etc. And we want to use this information to make our decisions. So we also want to extend our voice palette and support multiple languages. So right now we are working on adapting the English language to the system. We also want a simplified script editor so that we can offer this solution for smaller businesses that have simpler tasks, for example, like booking a table in a cafe. We can just provide them some pre-made script parts, and they can quickly make their script and use this technology. And we're also researching the history-based automatic script generation, so that if we go to a call center that was performing some tasks during a long time, they have a great deal of recordings, how their dialogues went. And we can use these recordings to actually create the first version of the script and then work it out to be perfect. So, to conclude, I just want to say that proper use of modern technology, of machine learning, it allows us to automate even such complex fields as human communications. And this is right now changing the future of our industry. So, if you happen to speak Russian, here are some demos that you can test with the recognition and the synthesis. And I can also give you one of these. It's a demo robotic system that you can call, you talk to it, and see this technology in action. And thank you for your attention, and I will be glad to answer questions.